In any discussion on this subject, you will often hear the word weight substituted for the word mass. In this particular context, it doesn't really matter, but it might help to clarify the situation if we define both mass and weight. Mass is the amount of matter in a body. Weight, on the other hand, is the force produced when mass is subject to gravity. A body will always have mass, but if there is no gravity, then it has no weight. For the purpose of this subject, the two terms are interchangeable. Aircraft are weighed in a draft-free hangar. On each and every occasion of weighing, a weighing schedule is compiled that states the basic equipment installed at the time, together with the mass and the position of the center of gravity of the aircraft after completion of the weighing procedure. The basic empty mass and center of gravity of a new aircraft are determined by the manufacturer using one of a number of weighing procedures. Light aircraft generally use the basic empty mass and center of gravity as the start point for loading calculations. The main type of equipment used to weigh light aircraft is electronic. This equipment uses strain gauges, which vary their electrical resistance with load. The center of gravity is defined as the point through which the force of gravity is said to act on a mass. For an aircraft, this is the point on the aircraft through which the total mass is said to act in a vertical downward direction, giving the aircraft its weight. The center of gravity is also the point of balance, and as such, it affects the stability of the aircraft, both on the ground and in the air. The center of gravity limits are the most forward and most aft positions that the center of gravity can be at which the aircraft is permitted to fly. The center of gravity limits are set by the manufacturer, defined in the aircraft flight manual, and are mandatory. They are defined relative to the center of gravity datum. The center of gravity datum is a point designated by the manufacturer from which all measurements are taken in the calculation of the center of gravity. The datum can be anywhere along the longitudinal axis of the aircraft, even if the axis is extended in front of or behind the aircraft. The arm is the distance from the center of gravity datum to the point at which the mass of a component acts, the center of gravity of the component. By convention, all arms aft or behind the datum are positive, and all arms forward of the datum are negative. The moment is the turning effect of a mass around the datum. It's the product of the mass multiplied by the arm. Since the arm may be positive or negative, a positive arm will give a positive moment, and a negative arm will give a negative moment. The basic empty mass is the mass of the aircraft with all its basic equipment plus a declared quantity of unusable fuel and oil. The traffic load is the total mass of passengers, baggage, and freight. The dry operating mass is the total mass of the aircraft ready for a specific type of operation, excluding all fuel and traffic load. This mass includes items such as crew and crew baggage, catering, and removable passenger service equipment. Imagine that these are the forward and aft limits of the center of gravity. Now imagine that the aircraft has somehow been loaded grossly nose-heavy. The center of gravity will move to a position well in front of the forward center of gravity limit. If the center of gravity is outside the forward limit, then a large balancing download is required from the tailplane, requiring large elevator deflections. Large elevator deflections will result in increased drag from the control surfaces, and because of the increased wing lift required to balance the tailplane download, increased induced drag. This causes reduced aircraft performance. Stalling speed will be increased because of the increased wing lift required. Longitudinal stability is increased. In other words, the aircraft will be slow to respond to pitch inputs. This leads to higher stick forces being required in pitch. Range and endurance are decreased due to the increased trim drag as the elevators must be used to trim the aircraft. The ability to apply nose-up pitch is decreased because the elevators, having been used to trim the aircraft straight and level, have less up range remaining. Imagine once again that these are the forward and aft limits of the center of gravity. This time, though, imagine that the aircraft has been loaded grossly tail-heavy. The center of gravity will move to a position well behind the aft center of gravity limit. If the center of gravity is outside the aft limit, then a large balancing upload is required from the tailplane, requiring large elevator deflections. Longitudinal stability is reduced. In other words, the aircraft becomes very sensitive to pitch control. If the center of gravity is too far aft, the aircraft will become unstable. Stick forces in pitch will be light, leading to the possibility of overstressing the aircraft by applying excessive G. Recovering from a spin may be more difficult because a flat spin may develop. Range and endurance will usually decrease due to the extra drag. Glide angle will be more difficult to sustain because of the tendency for the aircraft to pitch up. In the lesson on airworthiness on Disc 5, we learnt that aircraft are categorized according to the purposes to which they are put. We also learnt that aircraft are further categorized according to the maneuvers that they are allowed to perform. These are normal category, below 5,700 kilograms, and non-aerobatic. Maneuvers are limited to stalls and steep turns of 60 degrees. Typical limit load factors are plus 2.5 G and minus 1 G. Utility category. As for normal category, plus limited aerobatics. Typical limit load factors are plus 4.5 G and minus 1.8 G. Aerobatic category. Fully aerobatic. Typical limit load factors are plus 6 G and minus 3 G. Some types of aircraft may be allowed to operate in more than one category. For instance, the normal and the utility category. However, there will probably be different mass and center of gravity limits which are applied when the aircraft is operating in each category. An example is shown here. This is the mass versus center of gravity envelope that we saw earlier when we were working out the center of gravity for the loaded mass. The green shaded area is the envelope for the aircraft operating in the normal category. The same aircraft can be operated in utility category, but only if the all-up mass and center of gravity limits are changed. You can see here how the green shaded area has reduced considerably. The maximum all-up mass has been lowered from 2,325 pounds to 2,020 pounds, whereas previously this aircraft could only operate in the normal category within limit load factors of between plus 2.5 g and minus 1 g. Within the new utility envelope, it can operate within limit load factors of between plus 4.5 g and minus 1.8 g.